add on. Our today's lecture is all about complex number. It is a topic of mathematical physics. So, complex numbers. In today's lecture, what we are going to discuss is first, what is the form of the complex number? Means how it is represented and how it is different from real numbers. Second, we will discuss basic operations of complex numbers. That includes addition, subtraction, multiplication, division. All these things are known as basic operations. So now third thing which we gonna discuss is conjugate of a complex number. Conjugate number. Fourth thing and last, absolute value of complex numbers. Absolute value. So first thing is, these are the things which we gonna discuss. First thing, form. So let us see how we will describe a complex number. So complex number is generally denoted by Z A plus iota B, in which A is the real part and iota B are the imaginary part, and A and B are real constant. Real constant. So iota B is imaginary part. Why it is imaginary part? Because it consists of iota. And what iota is? Its value is square root minus 1. So iota B is imaginary part. Now A is real part. It is similar to the real number which we know or which we study, that is 1, 2, 3, 0.1 and that so on. Iota is denoted by I and its value is equals to square root minus 1. So iota square will become minus 1. Hence, now let us perform basic operations. See, basic operations of complex numbers. So basic operations, first of all, let us have two complex number, Z1 and Z2, which is equal to x2 plus iota y2. On adding both of them, Z1 plus Z2, which is equals to x1 plus x2 plus iota y1 y2. It means that the real part and imaginary part both added same. So what does it infer? It infers that summation of any two complex number give us a complex number. So what we came to know is summation of any two number give us complex number. Now let us see the subtraction. What about subtraction? Similarly, we have z1, z2. Now we become z1 minus z2. What happens? It also gives a real part and imaginary part, y1 minus y2. So it infers that summation of two, similar to the summation of two complex numbers, subtraction also gives a complex number. Now let us see the multiplication of complex numbers. Let us see what happens when we multiply two complex numbers, which is z1 and z2, or you can say x1 plus iota y1 into x2 plus iota y2. On multiplying, get x2 x1 plus iota y1 x2 plus iota x1 y2 plus iota square y1 and y2. So on simplification, we get x2 x1 minus y1 y2. Why? Because iota square is equals to minus 1 plus iota y1 x2 plus x1 y2. So multiplication also gives a real part and imaginary part. What is real part is? First, x2 x1 minus y1 y2 is real part, and iota y1 x2 plus x1 y2 is imaginary part. Therefore, we can conclude multiplication of two complex number give us a complex number. Now let us see the division of two complex number. Division of two complex numbers, which is z1 divided by z2. How can we write this? x1 plus iota y1 divided by x2 plus iota y2. So we will get what we will do in irrational number. Similarly, we will multiply by z2 minus iota y2 to eradicate the iota in denominator, because we know that I square is equal to minus 1. So x1 x2 minus multiplying, what we are doing is we are multiplying in numerator, and what we get is x1 x2 minus iota y2 x1 plus iota y1 x2 minus iota y1 y2 by x2 square minus iota y square. So in inference, what we get in denominator is x2 square plus y2 square. So in solving a numerator, collecting the real part together and the denominator, x2 square plus, now imaginary part, which consists of iota y1 x2 minus y1 x2. So we infer that the division also consists of a complex number, give us a complex number. Now we are going to talk about conjugate of a complex number. So, how for a conjugate of a number, first of all, we need to know how it is written. That is representation of a conjugate, which is equal to, denoted by, or you can say the representation is Z star or Z bar. And suppose Z is equals to A plus iota B, then its conjugate will be is equal to A minus iota B. That is, in case of conjugate, what is we done is that we just change the value or just change the sign of a imaginary part. Now talking about absolute value, which means the magnitude of a complex number, if we want to find in a real number, how we will find? We will find this the square root of complex number into its conjugate, which becomes A plus iota B into A minus iota B, which gives us square root A square minus iota square and B square, which is equal to A square plus B square. Why plus? Because iota square is equals to minus 1. Because iota square is equals to minus 1. So this is an absolute value of any complex number, or you can say the magnitude of any complex number. Let us recap what we have done till yet. Let us recap. First thing which we have discussed, Z is equals to A plus iota B is called a complex number. Complex number. Where A and B are real constants. By real constant, what I means, they are they can be integer, they can be number, they can be a whole number. So second, what we have discussed is all basic arithmetic operations. All basic arithmetic operations of complex number will give a complex number as result. So all arithmetic operations of a complex number gives a complex number as a result, which we have proved. Third thing, conjugate. So conjugate, we get Z star or Z bar. So what we will do is we change the sign of imaginary part. Here we take a z is equal to a plus iota b, so conjugate will become a minus iota b. Fourth, absolute value or magnitude of complex number can be defined by z into its z conjugate, which turns out to be square root a square plus b square. So I hope guys you will understand this first complex numbers lecture, and do comment and mention. We will continue this in next lecture. Thank you so much. Keep watching. Thank you.